Hey, welcome. I'd like to show a couple things. Here's a nice trick Blue can do. Look at that. She's like a T-Rex or something. Great job. That's the first thing. But the second important news that I have here is that this section is the one where we finally do our Instagram data, where we're finally cloning Instagram. And that's actually an exaggeration. We're only cloning the database. And even then, we're only doing like 7 or 8 tables, not 20 or 50 Instagram tables. But still, we're doing the basics, the important stuff: photos and comments and users and likes and following relationships, hashtags, all that fun stuff, all the relationships between them, and then all those joins. There's a lot of opportunities there. So this is sort of acting as a bit of a end cap on this course. It's not the end, but this is the last kind of data set that we're working with. And then I'm going to show you after this how to build a web app with MySQL. So that's also coming up, which hopefully is exciting. But this section, like I said, is all about Instagram data, really exciting stuff. Gonna basically build the schema. And then the next section is going to be a bunch of challenges and problems with it. Okay, let's get started. Hey everyone, just a quick note about this section and the following section. Both have to do with this Instagram schema that we're creating: users, photos, comments, likes, follows, hashtags, photo tags, all of this stuff. What I want to tell you is that this section and the following section, I'm actually keeping from the original version of this course. And it still works completely fine. All the data is the same. All of the commands are the same. The only difference is the interface that you'll see in the videos. It's slightly different. So up here, you'll see the code that I'm running, and down here, you'll see the command line. It's exactly the same as what you see here. I mean, it looks different, but it's the same concept where I have my workbench, I can have my files, and then I have the command line. But the major difference that is really nice about the workbench is that I can just click the lightning bolt to run this script. We've seen this many, many, many times. I don't have to do anything fancy to run this script. But in this section and in the following section, you'll see me having to type a command called source. See at the bottom here, source Instagram/starter data. I'm trying to run this SQL file and get it to execute as SQL. But we don't have to do that. Because, again, we can just use the workbench and click the lightning bolt. So that's the only difference in terms of functionality. Otherwise, it's just the appearance, I guess. Things look slightly different. And that could also be jarring. So I don't want to just shoehorn it in here, not tell you anything, and pretend that it's the same. But this is a really fun section, I think, and it was worth including. But it does look slightly different. So just keep that in mind. And again, you'll be doing everything in the workbench, or whatever editor you use, if it's dbGate or some other competitor, and then click whatever button you need to click to execute the query. Much, much easier than having to type a command. Hello, welcome back. So this section is going to be a bit of a capstone. Maybe that's an exaggeration. It's going to be a summary of what we've been focusing on in the last couple of sections. So there's sort of this subsection of the course, the last 3 or 4 sections that we're all focused on working with multiple tables, relationships between data, tables where we have foreign keys referencing other tables, talking about relationships or associations like a one-to-many relationship or a many-to-many relationship, and so on. And then also joins, which is what we were focusing on as of late. So this is going to kind of wrap that all together into something bigger, because so far we've really been working with 2, maybe 3 tables, modeling a single relationship like customers and orders. But now we're going to take something on a little bit bigger. We're going to focus on a bit of a case study. We're going to work with a site that you're probably familiar with, Instagram, and we're going to try and clone the database for some of the basic functionality. So we're not going to be diving into advertising and keeping track of our users' data and all of that. We're really focusing on the main big entities to a site like Instagram, things like photos and comments and users and so on. So again, we're not really scratching the surface as to how Instagram actually stores everything. We'll talk about what things work best for scaling. We'll run into some fun issues when we talk about how hashtags work and how you should store hashtags. So we will talk a little bit about performance, but this is really more about how do you design a schema for something that has, in our example, at least 7 or 8 tables. In Instagram, the real app, there's probably dozens of tables. But either way, it's a big step up from 2 tables or 3 tables max. And then the other thing I wanted to mention is that in this section, we're going to focus on designing the schema. It's going to be a bit of an exercise, but I'm also going to go through and do it myself. But then in the next section, I'm actually going to give you a bunch of data, like a ton of data. I spent a long time making this here. So this is what we'll be working with. You'll actually be inserting this so that for once we'll be able to work with big amounts of data, thousands of rows, and you'll see the impact that it has. And also, hopefully, it will feel a bit more realistic rather than, 2 or 3 things at a time. So that's where we're going. But in this section, we got to create the schema first. We got to understand what we need. So let's start by taking a look at a typical Instagram page. And yeah, some of you may know this. I'm in my spare time, I like to do photography, especially landscape photography, stuff around San Francisco. So I am using my own Instagram here, but that's not really why. I'm not trying to get more exposure or anything. It's just that I don't want to run into any issues with, permission or having rights to use somebody's images in my course. Okay, so with that said, the reason this is here, like I said, is not just to show you my photo, but mainly it's to help us understand and identify the key entities. So on this basic Instagram, this is from the web app, though most people use the iOS or Android app, it's the same entities, the same data. And the first thing, probably the most obvious, is users. So we're going to need some sort of users table or a way to store users. And then moving on, we've got a really obvious one, which are the photos. We need a way of storing images or photos. Now, we're not going to worry about how we actually upload photos and how, what data type we use to store them or anything like that. We'll just say that it's an image URL. So when we actually get to the exercise portion, I'll come back to that. So we need to store stuff about photos. And then we've got things like likes. So we need to store likes for a given photo, but also remember there are some complications because, I can't just click on this heart button, 10 times and add 10 likes. I can only like it once. So we need to have something there as well. Maybe there's something we can do with our database. Hint. And then we've got hashtags. And hashtags are a fun one. We're going to save that for last in this section because there's a lot of ways of doing them. We'll talk about at least 3. And there's a couple of advantages and disadvantages to each. So hashtags, though, are an important part of Instagram and of a lot of tagging in general is a lot of web apps, whether it's blogging or Twitter or something like Instagram. And then we also have other components that I couldn't fit onto one page, like comments here. That's really the big thing that we also need to be able to store comment information. And then there's one other big thing, which is followers and following. So the relationships between users, how do we store that? There's a couple ways of doing that as well. But on Instagram, the way that it works and the way that our database should work is that it's a one-way relationship. It's not like Facebook where, I send a request to someone and we only become friends if they accept or vice versa. But both of us have to be kind of consenting friends. On Instagram, I can follow somebody and they don't have to follow me back. Or people can follow me and I don't have to follow them back. So how do we store that in a database? Okay, so that's really what we're focusing on. There are obviously other things, like we're not going to store profile information. We're not going to store stuff about advertising, like I said. And that's just scratching the surface of what we're not storing. There's a bunch more. But we are going to store information, and I'm not saying these are the tables we need. We may need more tables. We may be able to get away with fewer tables. But these are the entities, the information we need to store. So users, photos, comments on photos, likes for photos as well, hashtags, which will apply to photos. We're not going to worry about hashtags inside of comments, which you can do on the real Instagram. We're not going to do that. We can talk about how, but it just makes it a lot messier. And then also followers/followees. It's kind of difficult to talk about the different roles there, but just relationships or friendships or whatever you want to call it. I just call it followers and followees or followings. So these are the main things we need to store. And the way that I'd like to structure this is I would like you to try and give this a shot. So you don't have to actually, insert data and do a bunch of exercises on your own, but I'd like for you to at least brainstorm how you would do this. What are the tables you need? I'm going to, in the ensuing 6 or 7 videos, go through each table we need and talk about my solution. But it would be great if you would take the time to just kind of think about it, jot it down, either draw diagrams out, create a schema file, and just write the create table statements, whatever you feel most comfortable with. If you want to get a whiteboard or post-it notes, whatever works. But think about how you would do this. If you were creating, it doesn't matter if you're a developer, if you know how to code in other languages or not, but if you were creating an application like Instagram with the functionality we described, what would you sit down and start with for your database, and how would you brainstorm it? So that's really what I'd like you to do. And then in the next couple of videos, I'll step through in bite-sized chunks. I want to make sure that these are short videos, which I know I have said before and maybe have not held up my end of the bargain all the time, but these will be shorter, and they'll go through my thought process and how I created it. Oh, and before I forget, if you're going to attempt this, when you're creating the tables that you need to store this type of information, just focus on the core essentials. So for something like users, you don't have to be, have a username and an email and a password and I don't know what else Instagram asks for, like a birthday maybe and a profile and all of that. You don't need that, just the basics, maybe like username and whatever else you need to have it work or have it relate or associate with all the other entities. It's easy to add the individual things to a table. Like for users, adding an email column is not hard. But then figuring out how you have users connected to likes, for instance, that's what I'd like you to focus on. Okay, so again, you don't need all the information you can possibly think of, just the key parts. All right, so this is the first video of basically talking about the tables we need and implementing the tables we need for our Instagram clone. And the first thing we'll start with is users. Users is a pretty obvious place to start. I guess another one might be photos, but users is at the core of everything, if you think about it, because users are connected to, photos, they're connected to comments, they're connected to likes. They're not connected to hashtags, but pretty much everything else relates to users. So what I'm going to do here is something super simple. Like I said in the last video, there's a lot more we could store here. Email, password, like 20 different things, location, city, IP address, all that stuff. We're just going to focus on the basics. So an ID, a username, and a created at. And created at will just be, the day the user or the timestamp when the user signs up. It will have a default value of now or current timestamp. Username is just going to be a varchar, and ID will be a primary key. And we'll be referencing this ID in other places. For example, when we talk about photos will have a foreign key referencing the user ID. So we'll go ahead, and the first thing I have is just an empty directory I made just to store this, and I'm just going to make a new file, and I'll just call it Instagram_clone.sql. I'll open that up, and this is where I'll work. So this is where I'll do a create table, users, and like we said, we're going to have an ID, we'll have a username, and a created at. So ID is going to be integer or just int. I'll do integer just because I've been doing int, but it's an alias for integer. It's good to see both. And we'll have it auto increment, and it's a primary key. Great. Comma. I'll come back to username in just a second. Created at, I'll do timestamp with a default of now. And you could also do current timestamp. And remember, you could do date time as well. Timestamp is just smaller. It's easier to store. Okay, so then we've got username. And we know it's just going to be a varchar 255. There's another constraint that we could add though, which is we want username to be unique. We don't want anyone to be able to sign up with the same username essentially. So we can add unique. And you might be wondering, well, then why would we have, ID be the primary key? Why not make username primary key? You absolutely could do that. But if you're going to have a foreign key somewhere referencing username, and you're working with a long string, if someone's username is, something massive like that, because we could do 255 characters, that's going to be slower and more annoying to search, not potentially, definitely slower if you have thousands and thousands of entries compared to a smaller integer. So it's good to have a primary key be an integer, but we can still have this unique constraint. And we can also add not null. We don't want anyone to be able to sign up without a username. Okay, I'm going to go ahead and make a new database to put this in, but I'm going to do it in this file. So I'll do a create database, and I'll also just call it Instagram or IG clone. And then I'll use IG clone just like that. So now every time I run this file, it's going to make this database, use Instagram clone, the new database, and create the table. And the reason I'm doing that is just one, to show you that you can. We haven't really seen using these commands in a file, but also as we go, we may want to rerun this and recreate the users table or another table if we realize we messed something up or we need to change something. We're not going to have any data in there yet, so it's super easy just to create the database again, drop it, then create it, and then use it, and then create the table of users. Okay, so with that said, let's try this. I'm going to do source, and I need to reference this directory /instagramclone.sql. Okay, and just to double check, describe users. That looks good. Okay, so if you are good with that, go ahead and move on. Next up, we're going to talk about photos, but I will spend a minute or two just adding 1 or 2 users so that we can work with them in this section. Remember, in the next section, we're going to have a massive data set that I'm going to give you. But if we want, we can just play around with some data. So I'll do an insert into users, and we'll just insert username. And let's just do 2 or 3. So we'll have Blue, the cat, and we could also have, I don't know, Charlie Brown. And then I'll just put myself in there, just like that. Okay. So what we could do now, if I resource this whole thing, I'll get an error because it tells me I can't create this database Instagram clone. It already exists. So I could either drop the database first, and I'm going to do that for now. You typically don't want to do that. You don't want to drop a database ever if you can avoid it. But if there's no data in there yet, or if the only data that will be in there is in the same file, like we're doing here, just testing it out, this makes it easy because I can just run this one command. It will erase the database, recreate it, and get all the new tables that I need in there, as well as the new data. So now I can do a select star from users, and there we go. We've got created at in there automatically, ID is automatic, and our 3 usernames. Okay, next up, photos. All right, moving right along here. We're working with photos this time. And the easiest way to store photos is just a single table, photos. But of course, they need to be related to a particular user who created the photos. So we'll have an ID, and all we'll store about an image itself is the image URL, which will just be a string. We could have added a caption as a varchar, not a string. We could have added a caption. We could have added location data. On Instagram, you can say where it was taken. There's all sorts of things that we could do, but we're just focusing on image URL in our case. And then a user ID, very important, foreign key pointing to users.id. And then we also have created at, just like we had with users, just a nice way to be able to, sort photos by most recent to least recent, or figure out the first photo somebody posted, or if one photo is posted before another, if one looks like this has actually happened to me, or people take a photo of mine and repost it claiming that it's their own. It doesn't happen often, but 2 times actually by the same person. And the person actually flipped the image, mirrored it, posted it, claimed that it was their own, but of course I could just show that mine was posted first, thankfully, because there's a date. It didn't really matter anyways, right? It's just photos on a social network, but still, having that created at in there helped me there. So let's implement it now. It's pretty straightforward. We'll just create table photos. We're going to have an ID. We'll also have our photo or image URL, whatever we want to call that. We'll have user ID and then created at. So ID is an integer or int auto increment primary key. We'll be referencing photos.id from other tables because things like comments are associated with a particular photo, or likes are, and tags as well. So we need that primary key there. Image URL will just be a varchar 255, but we should add not null. We don't want that to be empty or to be null. That's a big problem because there'd be no photo to display. And then user ID, that will be an integer. And let's also make that not null. A photo needs to be associated with the user. We can't have an orphan photo that has no user. And then created at will just be another timestamp with the default value of now, the time it's created. But we still need one more piece, which is our foreign key constraint, which is going to pertain to user underscore ID, which is referencing or references the user's table, the ID field. Did I spell that right? Reference, there we go. Okay. And that will create our photos table. So if I just resource this whole thing, now if I do show tables, we have both tables in there. If I do a describe photos, we got photos there, everything looks good. And just like before, if you want to stick around, I'm going to insert 1 or 2 photos in here associated with our 3 users, but I'm done with creating the schema, so you feel free to move on to the next one, which is comments. But if you want, you can stick around as I do an insert into photos, and we'll just do an image URL and a user ID. Those are the 2 things we have to supply ourselves. Values, and our first one, let's say Blue submits it, and we'll come back to the URL, but Blue's ID is going to be 1, and if we weren't sure, we could do select star from users. You can see Blue is 1, Charlie Brown is 2, and Colt is 3. So we'll just do something silly. Let's just say the URL is just random like that. I'll duplicate that a couple times. In Cloud9, it's Command-Shift-D or Control-Shift-D on a PC. And then let's, here's another random thing. This time it's submitted by Charlie Brown. Let's say Charlie Brown has another one as well, like that. Okay, and I haven't submitted any photos. That should work. If we run our source again, this time, so it dropped the database, recreated it, switched to it with the use command, created our 2 tables, inserted all of this data. Now if we can do select star from photos, and we should have 3 simple photos there with a user ID. We're now at the point where we could do a simple join if we wanted to figure out who posted these photos. So again, definitely if you feel good about this, move on. And don't waste time watching this, but if you want the practice, we could just do a select. Let's say I wanted to have the image URL created at and the name, the username of the person instead of the user ID. So we'll just do a select star to start from photos, join, and we'll just do a default inner join, users on, and we're going to do it where photos dot user ID equals users dot ID. So if we start with that, there's a lot there, so let's thin it out to just be photos dot image URL, comma, users dot username. Is that what it is? Username? Yes, just like that. Copy it. Okay, and now we can see Blue the cat created that and Charlie Brown created those 2. All right, and what I'm going to do just to set a pattern for the next few videos is move these joins and things that I'm just playing around with down to the bottom and comment them out. We don't want those to run, but I'll leave the insert statements here as well as to create tables. All right, moving on. All right, so we're moving on now to comments. And we did users first and photos for a reason. One is that they're simpler and essential to Instagram, but also comments is going to rely on them. Because if you think about how comments work, if we go way back here, these comments over here, this handy green box to draw your attention, are written by somebody, right? So it's not just a comment like awesome or banger, but there's also somebody who wrote the comment. So there's some association there. So a comment needs to be related to a user. But then these comments are related to a particular photo. These comments here are for this photo, not this one, right? So they're not just floating in thin air, but they're also related to a photo, which means we're actually going to have two foreign keys. So it looks like this. We have a comments table. Comments will have an ID, primary key. Our comment text, which is just, the text of the comment. I didn't want to call it text because that's a reserved word in MySQL. Even though it might work for you, it's just not a good idea to mess with that. In reserved word, meaning that text is a particular data type. It's something that's used in MySQL in the language. So naming a column in a table is not a great idea. It's like naming a column, integer. Okay, then we've got user ID, which is a foreign key related to the user's .id. So that's how we know who wrote it. Then we've got photo ID, which is also a foreign key, this time to photos.id, which is how we know which photo the comment is on. And then we've got our good old friend created at. So let's hop over to Cloud9. I'll do it down here after photos. So we'll do a create table comments. And our main things, we've got ID, we've got comment text, then we've got user ID, photo ID, and created at. So we'll start with ID. We'll do integer, auto increment, primary key, pretty standard. Comment text will just be varchar 255, as well as we want to make sure it's not null. We don't want anyone leaving empty comments. If you try that on Instagram, it just won't post it. Then we've got user ID, which is just an integer, but we also want that to be not null. We don't want to have a comment that's an orphan that's not related to a user. Same thing for photo ID. It's going to be an integer. And we also don't want it to be not null, or we don't want it to be null. We want to make sure it's not null, because then we'd have another type of an orphan, a comment without a parent photo. So we have these two relationships here. User and photo are related to comments. Okay? And we don't want either one to be null. And then created at, good old timestamp default now. But we're missing our foreign key constraints. So foreign key, and we'll start with user underscore ID, references, users, ID, comma. Then we've got another foreign key. This time we're working with photo ID, which references, photos ID. There we go. Okay, so just to make sure I don't have any typos here, add my semicolon, and I'm just gonna resource that. If I can find it, here we go. Looks good so far. If I do show tables, I've got comments, and I can do describe comments, and we're good. All right, so just like the last few videos, stop here if you feel good with this. If you want to see me insert some data and see how we relate things when we actually insert the data, I'm going to do that. But of course, move on if you feel comfortable. So if you're still here, what I'll do is insert a couple comments between or related to these three users and these three photos. And this is where it gets kind of difficult to keep everything straight, keep all the IDs and everything straight in your head. So we'll do an insert into comments, and we'll have comment text. Then we'll start with the user ID, who's posting it, and then the photo ID. Values. So let's say our first comment is going to be Blue commenting on this photo here, saying this is, or how about her comment is just meow. Okay, so that's the comment text. And the user ID is who's saying it. Blue the cat has an ID of 1. And I just, you can tell because we inserted her first, but of course if we went back to our select way back here, you can see, well, No, you can't see there. You can see here, her ID is 1. Okay. And then the photo ID, we'll just say she's commenting on this one here with photo ID of 2. And I'll duplicate that. So let's say somebody else commented. Let's say someone says, amazing shot on the same photo here. And let's say I commented on that. So that would be my user ID 3. And we'll do one more this time. Let's say Charlie Brown is commenting. I heart this. And Charlie Brown is user ID 2. And let's say he's commenting on the first photo that was submitted by Blue with user ID 1. So you can see how it gets a little bit crazy, but we can do that now. And make sure I have my semicolon instead of a comma there. This time, if we source it, everything looks good. We can do a select star from comments. There we go. We've got 3 comments. We could put a user ID in and a photo ID. I won't do that now. We'll do it as an exercise later with some more complex data. But of course, you can do that if you want a little bit of practice. All right, moving on to likes. So we've seen now users, photos, and comments. And likes are a little bit similar. They are like the comment schema because when we think about how likes work, on Instagram at least, you like something, you like the particular photo, let's say, it's corresponding to that photo, we need to have an association there. But then there's also the association between me, the person liking it, and the like itself. And that might not matter if we allowed for infinite likes. You know, if anybody could like something as many times as they wanted, just it was a button that clicked and it just kept going every time I clicked it, we could get away with not storing, user information with a like. But even then, it might be nice to see how many times somebody had liked something or how many likes, in general, how often do I click the like button compared to somebody else? It might help us figure out who's a bot. Like on Instagram, that's a big problem actually, are these bots that people write that go and just like photos, like things all the time, create comments that are just cookie cutter. It's kind of frustrating actually if you're a photographer because, you'll post something and then you get excited that you have, 100 people who liked it. And then it turns out a lot of them are bots. If you actually go try and look at them, they don't have any photos posted really. They always comment the same thing. Long story short, in this giant data set here, I actually coded in some bots that we'll be working with. Basically, people who aren't creating much stuff. They're not posting many photos, but they are liking a lot of things and commenting a lot of the same thing a lot of the time. Anyway, back to likes. It's going to look like this. We'll have a user ID and a photo ID and a created at. So our user ID is going to refer to a user's ID, and a photo ID refers to a photo ID. And there's really nothing else, right? There's no information being stored there, maybe, aside from the date or the time it was created, when the like happened. But what else is there to store? Maybe Instagram is doing stuff like whether it was liked from the web version versus the iOS version. Maybe they're storing, other information here, possibly. But for us, this is the basics. We just need a user ID and a photo ID. And every time, a photo is liked by a different user, we get a new like, just like this with the user ID and photo ID. So we'll start by coding this. You might have noticed that I didn't add an ID to likes. I'll explain why in just a second. But let's start by creating our table. So we have create table likes. And don't forget the semicolon. We've got a user ID and a photo ID and our created at. Let's start with created at. We often neglect it. Timestamp, default, now. Okay, nice and easy. User ID is just an integer. We don't want it to be empty. Same thing for photo ID. But then we need to set up our foreign key constraints. Foreign key, user ID references user's ID, comma, another foreign key, this time photo ID references photos ID. Okay, so now let's address why we don't have an ID here. And the main reason is that we don't need an ID. We're not going to be referring to likes anywhere else. If we were, it would be good to add an ID there maybe, but we're not having any table store information about likes. The other thing you might be wondering about is how do we ensure that there's only one like per user? Is there a way to do that in the database? Because right now, if I did this, I could just insert, let's say my user ID is 1 and a photo ID is 1. I could insert a like with user ID 1, photo ID 1, and then insert it again and again and again, and there's nothing stopping that. So what we really want to say is we want a unique combination of the two. There can only be one instance of every combination. And there's actually a way of saying that. We haven't seen it, but you can do this, primary key, and then we can just say user ID, comma, photo ID. So what this will do is basically not allow you to insert two, likes that are exactly the same user ID and the same photo ID. And I'll demonstrate that. If you feel confident, if you trust me there, you can skip, move on. We're done with the schema here. Let's just make sure that it runs. I don't have any syntax errors, of course. Okay, it does. But if you'd like to see me try it out, like the last couple videos, I'll do that now. So if you're still with me, all I'm going to do is take these photos and these users, and I'm going to have some of them like them. So let's take Blue, user ID 1, and that first photo, she created it. That doesn't matter. You can like your own photo on Instagram. So we'll insert into likes. And we have user ID, comma, photo ID. So the first one will be 1, comma, 1. So I'm inserting, or Blue is liking this photo. And then let's have Charlie Brown also like it. So that would be a, 2, comma, 1. And then we've got the next photo here, which has a photo ID of 2. Not this, remember this is the user ID who created it, but this has an ID of 2. So let's say Blue also likes that one. So Blue ID of 1 likes photo ID of 2, and she likes photo ID of 3. And then let's say I have user ID 3. I like photo with ID of 3. Okay, so let's start there. We run it, it works. There shouldn't be any problems at this point. But now if I try and do this, insert into likes, user ID, comma, photo ID, values, and I do 1, comma, 1. Well, that's not that. There we go. 1, comma, 1, which already is in there. Blue, user ID 1, and then this photo, add blah, 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 76 with ID of 1. We already have that like. But if I try it, you can see I get duplicate entry 1-1 for key primary. So the way it does it is basically combines the two, keeps track of the combination like that with the dash between it. So that's pretty much it. I will copy what we just did and add a note here. If you're looking at these notes later, just saying won't work because of primary key constraint. And I'll comment it out as well. We don't want to run that every time. Great. And next up, we're moving on to a fun one, which is relationships, following, followers, all that stuff. Welcome back. So we're moving on to capturing the relationships, the friendships between users. So we're talking about followers or followings or however we want to term this. I just refer to it as follows, but it's not really a great term either. But basically, how do we capture the data when I follow another user and they may or may not follow me back? It doesn't matter. I'm still able to follow them. And that's all we need to capture is this one-way relationship. And the easiest way to do it is with a single table that we'll call follows. And all that it is two user IDs. So both of these are both of them are foreign keys referring to a user ID. A different user ID that's important. We can't have a user follow him or herself. So they're different IDs. And I called them follower ID and followee ID. You could do, user 1 ID and user 2 ID, but the idea here is that you can tell who is following who, that the follower is the person following the followee. It's a nightmare to try and discuss here. So let me give you an example. Here's our table of users. So we have 3 users, Tommy, Blue Cat, and Cold Steel. And they have an ID of 1, 2, and 3 respectively. Okay, so here's our follows table. And the first thing, let's say that Colt, me, decides to follow Blue. So that means, follower ID is 3, follower being me, the follower. Who am I following? 2, Blue, the followee. But she doesn't have to follow me back. And she doesn't follow me back, at least not yet. If you look next, I'm following user ID of 1, which is Tommy. Speaking of Blue. Yes. Okay. Let's see, where was I? So I, with user ID 3, follow Tommy. Okay. And then you can see now, Blue, whose user ID is 2, finally follows me back. She decides I'm a good owner, and she wants to follow me on Instagram. But the key thing here is that it's a one-way relationship. Here we have, I'm following Tommy, but Tommy does not follow me. And this is all we need, the structure to encode that information. A couple points we should make, that these are both foreign keys. Created at, it's just good to know if you want to keep track of, when people are being followed. Again, not essential, but it's something that Instagram definitely is tracking, friendship date or something. And then also, we don't want to have duplicated, follows. So I don't want to be able to follow Blue again. So we need to enforce that these are unique. The combination of these two in an order. So as you can see, 3 and 2 is here, and we can have 2 and 3, but we can't have another 3 and 2. Okay, so let's get to it. We've got follower ID, followee ID, and created at. And we won't be needing a primary key ID or an ID integer that is a primary key because we won't be referencing these friendships or follows anywhere. So create table follows. If you have a better name, feel free to use that. And the first thing we have is our follower ID and our followee ID, and then created at. Okay, oh my gosh. Okay, so let's start with created at, timestamp, default now, perfect. Then we've got follower ID and followee ID are both integers. We don't want them to be null. Just copy that on over. Put our commas there. And now we also need to officially declare these as foreign keys. So that would be foreign key, follower ID, references, users ID. And we can just duplicate that line and just change followee ID. It also references users ID. And then the last thing, as I mentioned, is we want to enforce that you can only have one of a given relationship. So if user ID 1 is following user ID 2, that can only be in the database once. But user ID 2 can follow user ID 1. Anyway, so to do that, it's just a matter of primary key. And the order that we actually put them in here won't really matter. I mean, it makes a difference to MySQL, but for us, it won't matter. Followee ID. Okay, and so that creates the table for us. Let's just check that everything works. Looks good. Let's do a describe follows. Good. All right, so just like the last couple videos, we're done. If you want, stick around and I'll play around with some data and show you that this primary key constraint is working. Okay, so if you're still here, let's try doing an insert into follows. And we'll have our follower ID first, and then our followee ID. Gosh, it starts to just sound like gibberish after saying it enough times. So let's say that we start off, we've got these 3 users, right? So Blue follows Charlie Brown. So that's going to be 1, 2. And we'll also have Blue follow me. So that's 1, 3. And then let's say I also follow Blue back. So that is 3, 1. And then let's say that, who do we have? Charlie Brown follows Blue. Let's say Charlie Brown follows me. So that's 2, 3. Okay. Let's try inserting them. Looks like it works. You can do, select star from users, from follows. Great. We got follower ID, followee ID, and created at. And then the true test is if I try and reinsert a relationship, like insert into follows. Getting sick of this follower ID, followee stuff. We're almost done. So let's say I try and insert this friendship, 1, 2. So that is Blue following, or let's do 1, 3. It's Blue following me. She loves me so much, she wants to follow me again. If we try and do that, it's a duplicate entry. But as we saw, you can see here, we already have 3, 1. So if I did do, if I do 1, 2 this time, which we also already have, that's Blue following Charlie Brown. It's a duplicate entry. But if I switch the order and do 2, 1, that's permitted because we don't have that in here yet. But now, of course, it's a duplicate entry. So the order does matter, right? Who's following who? Okay, so hopefully that makes sense. We're moving on now to our final piece, which is tags, hashtags. And finally, we've arrived at our last entity to store, which is hashtags or tags. And we saved this one for last because, as I mentioned in the intro video, it's the hardest, I guess. Well, it doesn't have to be, but there's a couple different solutions we could go about, and I wanted to have a discussion about which is best, if there is one answer. So let's step through 3 potential structures that we could use. And remember, the way that this works is that one photo can have, 10, 20, 50 hashtags. I do think there is a limit on Instagram. I mean, you can keep adding them as many as you want, but only 30, I believe, actually will show up. Or it's not that they won't show up, but it's that when you search for a hashtag, your photo will only show up if you use less than 30. Anyways, we're getting off track here. But the idea is you can add hashtags to a photo, but then you can also, go click on a hashtag and see all the associated photos with it. So here's one way we could structure it, which might seem maybe the least obvious to you, which would be to do it like this, where we actually just have our photos table, but we add a column called tags, and it's a string, just a varchar that just has our tags, and we could separate them by the hash sign, the octothorpe, or by spaces or dashes or something, but we're just storing them together. And this could work, and places do use this. I've seen it suggested, at least. I haven't seen it in practice, but you can imagine how it would work. To add a new tag into something, you'd basically just take all the other tags and then concatenate in at the end a new tag, or at the beginning. And then you could have an order to, figure out which ones were posted first, I guess, based off of that order that they're in. And it's pretty simple. If you wanted to find all photos that are tagged with cute, you just basically have to use like, where tags like cute. But then, as you can see down here, there are a couple problems. Let's start with an advantage, which is that it's very easy to implement. You don't need any other tables, but there are a couple disadvantages. One is that there's a limit to how many tags you can have in there, which is the length of, whatever the column is. If a varchar, whatever the maximum length is, you can only put so many in there. The other problem, or another problem actually, is that you can't store additional information, like, if we wanted to store the first time a hashtag was used. If I wanted to be able to see the first person to use the hashtag, whatever, cat or something, I'm not storing the time that something was tagged because, on Instagram, you can add hashtags after the fact. I'm sure they're storing that when they're tagged so that they can track trends as hashtags come and go. So it doesn't allow us to store additional information like that. And then the other thing that's kind of important is that you have to be careful when you're searching for stuff. So if I was trying to find the hashtag food, and I wanted to see nice food, beautiful food, so the hashtag is just food, well, it will return this, which has sad food, if I'm just doing like food. So I'd have to be careful, and I need to add spaces maybe to make it easier to separate things out. Basically, you just have to be careful. There's ways around it. We've seen them before, how you use search with like. But the point is, this is an easy solution, but it's not going to be the best, and it's not the best for us right now. So another solution is to use 2 tables. So we have our photos as our photos table currently is now, but then we have a tags table where we have our tag name, in this case cute, and then a corresponding photo ID. So, if this photo with ID of 1 is tags cute, we put it there. And then a photo with ID 3, which is the selfie here, is also tagged cute. And then photo ID 2 is tagged with microwave, and 3 with ego, 3 with smile, 2 with gross. So as you can see, we can have a single photo with multiple tags, like here, where we have this selfie. ID 3 is tagged with smile, ego, and cute. And we can also have tags that are applied to multiple photos, like cute. It's applied to the first photo and the third photo. So this works. There's unlimited number of tags. That's an advantage. We don't have to worry about how many can fit into the string. But a disadvantage is that, for one thing, we are storing, these tag names over and over and over, and these are strings, and that it's maybe not ideal to store all these different strings and have duplicated data. But it's not a big deal. The duplication isn't the problem. Really what it comes down to is that this is actually slower than the previous solution when it comes to things like inserting or updating or deleting. But then another problem is that it's actually slower than the previous solution. So in just a moment, I can show you a comparison that I didn't do, but there's a great article that I found where somebody does a speed test between these, the 3 solutions, to figure out when they perform best. So this is not one we're going to use either, but solution 3 is, which maybe you got, it involves 3 tables. So we have our photos table, unchanged. We have a different tags table. So this tags table is just a tag name and an ID. And then we have a middle table, a join table called photo tags or tag photos or taggings or something, whatever you want to call it, which is an instance of a hashtag being applied to a photo. And all that it is a photo ID and a tag ID. And that's it. So in this case, photo ID 1 is my cat is being tagged with cute. And then the same photo, my cat is being tagged with pets. And then we have, we can keep going. My meal is being tagged with microwave. And my meal is being tagged with gross, and so on. So we have these, 2 columns, and that's pretty much it. The advantage, again, just like the previous one, there's an unlimited number of tags. And we can also add additional information. So if I wanted to, when a tag is created the first time over here, I could store the first time it was created. And then over here, every time it's subsequently used, I could store, the time it was used or something. And so I'm sure there's some interesting data you could garner from that, or the location of where in the world it was used or something like that. The time of the day, I don't know, day of the week, whatever. And we also have less duplication of the tags over here. But then there are a couple problems, and they really come down to just more work. So when we're inserting something, if it's the first time a hashtag's been used and it's not in the database yet, we have to create it, and then we have to associate it with a photo using photo tags. And the same thing when we're updating. We have to... What? She just vomited. Anyway. And then we also have to worry about orphans. We should always all be worried about orphans, but in particular when we're talking about these tables, when we're deleting something, right? If we delete a tag for some reason, which Instagram does, if there's a problem, if something is being misused or somehow being, controversial, they can be removed. And so then we just have to make sure when we're removing it from here, we also need to remove it from all associated photo tags. So it can be a bit more complicated. But basically it comes down to the cost of having this nicer structure is that it's just a little more work. And just as an end note here, I did mention earlier that there is this great article online, this guy who does speed tests of different ways of doing tagging. And it's written up. I'll include the link along with this video if you want to read it. I'll just spend 10 seconds talking about it. But basically, he does some tests here to show that depending on, one, the size of your data set, this example with a smaller data set, the second and third approaches I showed you with multiple tables are actually faster. But then as we get a larger data set with thousands of tags, it actually changes. So it's just interesting to note that and to read. But also it talks about how much time it takes to insert compared across the 3 different versions. And it's just an interesting article. But if you actually look at his conclusion section, which is probably what most of you care about, where is that? Is that he actually thinks that it would be best to have, if you're working on a huge app, to have 2 versions. The first version I showed you and the third version I showed you. And basically they are perform best in different situations. And this is getting into the woods a little bit, but basically the version that we're going to go with, the third one with 3 different tables, is faster if you're working with common tags, things that are used often. But if you're searching or you're trying to do joins with like rare is the wrong word, but uncommon tags that just aren't used very often, then it's actually slower, and it would be faster to do the first version I showed you where you store them as text. So this guy is suggesting to use a combination of the 2, which we're not going to get into, but it's just interesting to note that there isn't one best way, and that it really comes down to your needs, what your app needs, the product needs dictate. And in all likelihood, as an app like Instagram grows, or especially when it started out to where it is now, its schema, its database has undergone multiple big overhauls and changes. Probably not just the schema itself, but the database, whether it's going from something like MySQL to another type database, or a bigger change going from a relational database like MySQL to a non-relational database. So it's really hard to say what's best, but it's interesting to take a look at somebody who's actually crunched the numbers, and even after doing that can't necessarily give a definitive answer, because the answer is it depends. All right, so this will be a quick video where we just implement the 2 tables we need. They're both very simple. So tags is just an ID and a tag name. Photo tags is a photo ID and a tag ID. Okay, so here I am in Cloud9, and we'll start with our tags table. Create table tags, and all we need is an ID, which is an integer, auto increment, primary key, and then we'll also have our tag name, which is just a varchar 255, and we want to make it unique. We don't want to have, oh my gosh, if I can spell unique, we don't want to have any duplicates in there. And then after that, it would be nice to add a created at, like I said, so we could store the first time a tag was used or created. And that's it. So that's our tags table, this table here. Now we've got to worry about photo tags. So we'll do our create table photo tags, or taggings, which is also nice, I guess. Well, neither's nice, but also works. We don't need an ID. All that we need is a photo ID and then the tag ID. And those are both going to be integer, not null. There we go. And then on top of that, we need to add our foreign key constraints. Foreign key photo ID is referencing the photos table ID field. Duplicate that. Tag ID is referencing tags table ID field. We also want to make sure that a user can't tag the same photo with the same hashtag multiple times. And that's an easy fix. We just do our same primary key with 2 items, photo ID and tag ID. And that just ensures that we can't have multiple instances of the same photo tags. All right, don't forget our semicolon. It looks like I'm missing this comma here. There we go. Now if we try that, and we look at our tables, there we go. We've got comments, follows, likes, photo tags, photos, tags, and users. And that's it for our schema. We're done. So in the next section, if you'd like to tap out now, move on to the next section, I'm going to give you a massive file with a bunch of data that I created. It took way too long to do, that we'll be able to do some exercises with and get some practice working with a bunch of tables. But if you do want to see me just insert a couple tags and photo tags, I'm going to do that now. So if you're still here, I'm going to do that. I'll start with inserting a couple tags, and all we have is tag name And just to verify that, if we go back up to our tags, it's just a tag name that we're inserting. So let's say I'm inserting the string, adorable, and we could have 2 more. Let's say cute, and 1 more would be, I don't know, sunrise. Okay, so that will insert our tags. Can make sure that that works. Select star from tags. There we go. We've got our 3 tags. Now we associate them with photos. And so we've got 3 photos. I'm not, it doesn't matter what they are, but they have an ID of 1, 2, and 3. So if we want to do an insert into, if I spell insert correctly, photo tags, we'll start by taking the photo ID and then the tag ID. Okay, values. And let's say the first photo is tagged with adorable. And the first photo is also tagged with cute because that has an ID of 2. And then we'll say the second photo is tagged with, I don't know, sunrise. And then the third photo is also tagged with cute, like that. Okay, so we can rerun this. Let's do select star from photo tags. There we go, looks good. And now the true test is, can we still insert something that shouldn't work, like a duplicate? We already have, 1, 1. So insert into photo tags, photo ID, tag ID, values 1, 1. And we get duplicate entry. So that's good, works perfectly. But as you can see, the other order works fine. 2, 3 or 3, 2 are not the same thing at all. This is saying the second tag, or this is saying the second photo should have the third tag. This is saying the third photo should have the second tag. Quite a mouthful. All right, so we're done here. Next up, we're actually going to play around with data. Like I said, I'm going to give you a giant file. Hopefully it's fun. And if it's not, well, we're basically at the end of the course. So just hang in there.